knows it so well he's bored. Okay, so I have my A, I have my B. Kiddos, just practice with these problems from the title at the top, review number 5, Understanding Big Theorems. It was the end of the second video assignment. And so I was hoping that they were jumping to the conclusion of MVT that there is a C in between A to B. And Andy just said, for those of you joining the recording, that I have -2 to 1. Such that, what's my conclusion? F prime of C is equal to what?
Jeez.
And why am I going straight to plugging in stuff? Because I know what F of B is? Wait a minute, that's not F of B, that's F of what? Stink, I need the final minus the initial. Whether or not the number is bigger or smaller. So I need my F of B minus F of A all over B minus A. And so I get -9 all over +3, which would be? Now, careful, hold on. Didn't they already tell me that? Right? Okay, so hold on. They're saying, when is this going to be guaranteed? Which could guarantee that there is a number C? What do you guys notice? Which could guarantee that there is a number C? Okay.
Wait, what do you got?
F is, well, because we're trying to answer what could guarantee this. This is how it's true. It's true because MVT, right? So we're trying to say which of these would meet the conditions of MVT. And for MVT, 2 things need to be true. I need to have differentiability on and open, right? But I also, yeah. Does differentiability prove continuity? Yes or no?
No. Yes.
Yeah, there's a forever card for that, right? The forever card says if a function is continuous, sometimes it's differentiable. It can't be sharp, it can't be vertical, it has to be smooth. If it's differentiable, it's always continuous, but here's the dilemma. Differentiability on open, why isn't it enough? What does continuous have that differentiability doesn't? Closed. So the problem is, just because I have differentiable on open, I have continuous on open, but I don't have continuous on closed. I don't know the endpoints from clue letter B. I don't know the endpoints from clue letter B. If F is never increasing on the closed interval, what does that mean? It's either always, if it's never increasing, it's either always decreasing, or it can be constant, or it could not exist. Well, why would not existing be a problem? It wouldn't be increasing if it's not existing. Then MVT wouldn't apply, so that's not going to work. Just because it isn't increasing, I don't know what it's doing. Maybe it doesn't exist. Maybe it has an asymptote.
Never mind, Noah. We're not going to get 3.
What about letter C? F has both a maximum and a minimum on the closed interval. Ooh, what theorem is that? A maximum and a minimum on the closed interval. That happens if I have extreme value theorem, and extreme value theorem says I just need the function to be what?
Differentiable or continuous.
Just continuous, yeah. So actually this one tells me continuity, but it doesn't tell me differentiability, so that's not going to work. This tells me 1 point. Wait, how have we eliminated everything? Because I never asked you guys to read the problem again.
Bruh.
What had they told me in the very beginning?
Let's
go! Let's go! We're actually crazy. Never mind. 3 inbound.
As long as it says continuous on a closed interval somewhere, I just went ahead and skipped to these little clues and said, yay, let's go! And then I was like, stink, I'm just supposed to be answering the theorem. I didn't have to do any of that work. I just had to think of continuity, and if I read the problem, I would have seen that. Differentiability, I would have seen that. That's not enough, but both of them are.
That's crazy. Miss Michelle, can you not kill my confidence?
I'm so sorry. I was making sure you had read the problem and didn't just pick the one that looked nice. Number 9, let f and g and h be functions such that f is always below g in between -1 to 3, and the limit of...
Oh,
Yeah.
so for the first one, since it says that it's continuous, And we know that MPT applies, that's how we know that it's differentiable. That we did.
Because it says continuous, and I know that this is going to be proved by MVT, then I needed the differentiability in order to have that be guaranteed or applicable. Does that make sense?
Yeah.
Yeah.
Are you serious?
Who's H? I'm just trying to figure out if H has any. Oh, there's just, I don't know if H is. Okay, but anyway, which of the following must be true to ensure the limit as x goes to 2 of f of x is equal to 4? This is a little bit of a confusing one in some ways, shapes, or forms, unless you remember this little guy that I haven't made AB kids memorize, but we've mentioned, and we've used it at the very beginning of the year. Does anyone remember something to do with a sandwich and the squeeze theorem?
Sandwich.
Yeah.
Like a sandwich.
And by a sandwich, I mean a sandwich inequality. If I know, this is especially true with, oh my goodness.
That should have been my senior course. Miss D, can you use that in your future lessons?
In my future lesson, say it one more time. What was it?
Life is like a sandwich. No matter what way you flip it, the bread comes first.
I mean, at least he said it does, and he didn't say it should, because, I mean, I'm not sure it should come first. Anyway, here we go.
It must.
Clever. The squeeze theorem says I can know about what's happening in between two functions. And if they show right here that f is less than g, and if I'm trying to figure out what's going on with f, all I need is to have it get squeezed in between. So if its upper bound is going to 4, then I need h to be its lower bound. If h is its lower bound, then f gets squeezed in between because g and h both have the same limit. If I can just put f in between the two, here we go, Andy, here's your bread. If I can make the g and h my bread and f is squished in between, if their limits are 4, then his limit is 4. So therefore, all I need is for h to be below g. I need it to get squeezed. That's the only way I'll know for sure.
Wait, can you explain the lower bounding?
Yeah. The squeeze theorem is kind of like a sandwich in the sense of a sandwiched inequality. We used it for like sine of x over x way back in the day.
Mm-hmm.
If I can say what's always above and what's always below, and if they are in agreement for something like a limit, then he's going to get squished in between and have the same.
But couldn't it also be D because like the limits agree, so it would mean it's continuing?
Which one?
D.
Ah, but careful, D doesn't say anything about the limits, it just says that they're all continuous.
Yeah, but I'm saying if the limits are equal to each other, and then it's saying that that limit of x of f of x is equal to the same thing, couldn't you just
Oh,
say,
I see. Continuity isn't saying all their limits are the same. All we know is that this one singular limit of g and h are the same. But we have no idea how that compares. Like, g and h, if we didn't put h at the bottom, then we could have, like, I don't know, here's h going here, and here's g going here, and then little f is like, and they're all continuous. And, like, the g, actually that wouldn't always be higher. The g could be this guy, and here's my 4, and then here's my h. If h isn't always below f, f could be below g and could be continuous, meaning having its own little limits. G and h are totally agreeing at 4, that's great and everything, but f could be doing his own little thing way down somewhere else unless I have, wait, h needs to be squeezing him. So therefore, here's my g, and here's my line. And then if I know that h, if that's what's going on at 4, then I know they all agree there. I don't know if that makes sense, but if it gets squished in between or squeezed in between, I'm good. If it doesn't get squished or squeezed, it can be below and not at the same point. Okay, so that was not the end of the theorems, because hopefully you never end the theorems, at least not before the AP test, because the theorems are big and nasty, but you do have the video from Mark and Verge last year, and you also have the video from Mark and Verge this year, as far as giving you some extra content. Of course, you have all the AP daily videos too, but ain't nobody probably have time for that right now. Let's go check out some applications of integrals, review number 6. We're finishing off these videos, review number 6. Take a deep breath and say, whew, there are fewer words and fewer tricky concepts. There are fewer words and fewer tricky concepts. So check out these guys. Let me just go ahead and do 4 minutes again. No calculator, you guys can see that via the picture. Via the picture? You say via or via? I think I say via. Can you do some integral stuff? My ones on your phones. Are you ready? 4 minutes. And 2 multiple choice.
Nah, bro.
I was actually looking at Noah, but yeah, we could totally roast Sarah. I think he was just looking around. He was like, huh? What? I know. He's still waking up. Okay, let's go. Let's go.
What's one do you problem?
2.
Woo! It's a good day. It's a good day. She's on it.
2,
I don't know.
Whoa.
She definitely will be by lunch though, because she and Mrs. Kratz are putting on the shindig. They might be out shopping or something.
Oh, okay.
I could see them doing that. Or like decorating. P.S. If you're ever running out of time, and I want you to practice it right this second, if you're ever running out of time, what do you do to finish those last few seconds? You fill in bubbles, right? At least get an answer down. Who knows if you'll be right or not, even if you don't read the question. If you're ever running out of time. So when it gets down to like 15 seconds, you just gotta pick something. You should do that on the AP too. You always pick something. If you need some inspiration, check out the basketball poster in the back.
Facts. It's a great quote. Huh? It's funny.
It's funny. Hey.
What was it? It was funny.
Oh, his chuckle is funny.
Oh, bless you.
What are you guys doing?
Oh, so I don't even want to have sleep.
What did you do?
At least got 3. It's funny.
What?
That's your fault.
Yeah, you're like an old man. You play poker.
Or that late. You just decided to play. This is more fun.
Worst comes to worst. Is anybody heard of this? They'll assume.
I thought like you were the only one.
Okay,
who
but
was
it
doing
says, don't know, so I just put don't know.
Pretty sure my dad's okay with it. When I asked my mom, my dad was okay.
That's awesome.
And he didn't say no. He didn't say no or anything. He was just silent. And my mom was yelling at him.
Well, I mean, it's either or.
Yeah, like
She definitely wants it.
Alright, here we go.
I don't know.
You got this in your transcript? Like, you're fine. Well, if you do it,
Dap me up.
Question! How do we go from an original? No. How do we go from a rate? How do we go from a derivative? How do we go from a rate or a derivative back to an original? Integration. But when you do an integral question, what do you need? Starts with a B and ends with an ounds. So if I'm going to go from 1 to E, or I could go the other way from E to 1, of f prime of x dx, someone help me with FTC, one of the key applications of an integral. FTC tells me, what does this equal? F of B. So use that f of x, Andy, but it's f of x from 1 to E, so it'll be f of E minus f of...
Oh, my bad.
Do you see it? And now all of a sudden I have pieces. I have pieces that I can plug into. For instance, I know who this guy is, so I can just go say, haha, I'll plug it in. I don't know who this guy is, so it's like, okay, keep this one as your, like, I don't know, we'll get there in a second. And so all we need to do is take a definite integral from 1 to E. So I can say that f of 1, if I do a little algebra, f of 1 is equal to, I'm adding it and subtracting it, f of E minus the definite integral from 1 to E of my 2x minus 2 over x dx. I know who this dude is because they told me, so that's e squared minus 2, and I'm like, okay. And then minus, now I need to actually find this guy. Guys, what's the antiderivative of 2x?
X squared.
X squared minus, why did I not rewrite this to be 2x to the negative 1 power for power rule? What am I hoping you remember?
Oh, that's what I was.
That's going to be an,
That's crazy, bro.
you see it? That's going to be an ln. Because that is 2 times the integral of 1 over x dx. And if you tried power rule, you'd have a division by 0, which is bad news. Bad news bears. My sister's favorite book growing up. And this would be 1 to E. I gotta plug stuff in. And that all is equaling exactly what I need it to. So I'm going to keep going. So that's going to be E squared minus 2 minus, plug it in, E squared. Minus a minus would be plus. Actually, no, that's dangerous. This is very dangerous, what I'm doing. I should do minus and big ol' like fat, let's plug it in. So I'm going to have E squared minus 2 ln of E. That's f of B minus f of A, which is 1 squared minus 2 ln of 1. I know, if it was an FRQ, you'd be done, but we're not on an FRQ.
Dang.
Do you guys know that ln of 1 is 0? Do you remember that? That just goes away, poof. Then I have things like an E squared minus 2 minus E squared, which is going to make those go poof, poof. Then I'm going to come back and I have plus, hey guys, what's ln of E? That's 1 because it's e to the 1 and that comes down. This is e to the 0 comes down. This is e to the 1 comes down. 2 times 1 is 2. Minus 1. But, I have a plus 1. So I have minus e squared. I have plus 2. I have plus 1. That's going to end up being, and the 2's cancel. Dun, 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 dun. Dun. Last man standing. Dun. Whew. 2 over x went to 2 ln of x. All you gotta do is plug in your e and plug in your 1 and take whatever you find from your definite integral and subtract it from f of 1.
Miss D, are you allowed to do it a different way and still get the right answer?
Maybe. How'd you do it though?
I found an antiderivative
Good.
of f of x, or f prime of x, and then I just made that, kind of, you used like a point like e comma,
Ah, as your initial condition?
yeah, and then I used that to find
That could work too. So what Josh did is he saw this as a little differential equation. He was like, hey, that's dy dx, multiply the dx, integrate both sides. I get y is equal to x squared minus 2 ln of x plus c. He saw this little guy as his initial condition and said, plug it in, in the sense of, I'm going to plug in an e and an e, and he could have set that equal to e squared minus 2. He would have found his c to be the e squareds cancel. That's minus 2 plus 2. That cancels. C ends up being 0, right?
Yeah.
And so then he just went ahead and said, yay, let's plug in. Actually might have been easier computationally. Plug in 1. So then it would be 1 squared minus 2 ln of 1 plus 0. That's 0, and you get 1. Yeah, that's completely legal. Sorry, my brain just goes straight to FTC and then solving with integration is not changed, kind of. But yeah, solid. A particle moves along the axis at any time its acceleration is, okay, cool. How do I get from acceleration to position, cool kids? How do I get from acceleration to position? Anti-derived how many times? Twice. To get to velocity, I'm going to have to go back once of the 9 cosine 3t dt. At which point we would go ahead and get, if you did your u sub properly, I'm not sure if I'm reviewing u sub today, but u would equal to 3t, du would equal u prime, which is 3 dt, but be careful, we divide by u prime. So we would actually end up with 3 sine of 3t. Feel free to double check it. Derivative of sine is cosine. And it's going to have a 3 and times a u prime, which is 9. And it's like, woohoo! But they tell me an initial condition. So Josh, yeah, I would have totally done like your strategy down here, just naturally. But it definitely worked up there too. V of 0 says plug in 0. Sine of 0 is 0. And that's going to equal 4. So C equals 4. So if I... No, go ahead. I'm plugging in my initial condition.
Oh, thank you.
And sine of 0 is 0. I think of the graph. However the graph goes. There it is. Sine of 0 is 0. Or you can think at 0, my y value is 0.
Wouldn't you just be able to plug it in as the C automatically since it gives you that observation?
Careful, that's only in super basic, like free fall models where I'm talking about parabolas. That's the only time you can just assume that C is the initial. Otherwise, like what if this was a cosine? That would have been 1. 1 times 3 is C would have been not 4. Does that make sense? Yeah, solid question though. That was only a shortcut in that one like free fall gravitational model section. So I'm going to go ahead and take my velocity, which is 3 sine of 3t plus my C that I just found. I'm going to anti-derive. I'm going to land at a negative. I have to divide by 3 again, so I'm just going to have cosine 3t plus 4t plus c. I do have an initial condition again. So I can come and I can plug in. But you could also maybe narrow this down just a little bit. For instance, that doesn't have a negative cosine, so forget him. That doesn't have a negative cosine, so forget him. Maybe even process of elimination. Do you guys see that there are 2 of them with negative cosine? If worst comes to worst, time is short. Assume that that's the one that's closest. You have a 50% chance of getting it right without even solving. Not always, but sometimes. The question is C 0 or is C negative 1? So Lucas, here you go. Cosine of 0 is 1, right? So then this leads me to negative 1 is equal to, cosine of 0 is 1, negative 1 plus 0 plus C. C is equal to 0. The question isn't did you, the question is could you, right? It's not so much did you, but could you. You guys ready for a verge question? Here's a verge question. On your marks, get set. Go. The cool thing is it shows you her steps. You just have to find her mistake. I kind of like this question. Ready, set. There's some stuff to read, but the nice thing is you don't really have a lot of math to do. Let me get out of the... Alright, let's check it. Oh, that was the apple pie one. Hold on, I'm on this one. Vert. So what'd you guys see? I heard you talking it out. Lucas, Fletcher, go.
Flesh dog.
I was, because it goes to ln, which would just be 1 over u, but it would technically be like 1 over u to the 1/2 power. So when you bring the u to the 1/2 power up, it's just to the negative 1/2 power, which then you would just do the reverse power rule. It's not up to the negative 1 power.
Yeah, deriving ln of u would give you 1 over u. I mean, remember, every integral should be able to be checked. Every antiderivative should be able to be checked by deriving. The derivative of this would be 1 over u times u prime. It's not there! Okay, this is not the right answer. It's not just 1 over u, it needs a u prime as well. So yeah, make it u to the negative 1/2 and anti-derive, etc. And it's asking where does the first error occur, so you guys would have answered letter B, right? Okay, let's play with our calculator where we have some less work to do. I'm going to answer Benny's question before I change the slide. But get your calculator out and open, because these questions, there is not a lot of work to do. It's more understanding to get, and then using that tool to get you to right answers, which is gorgeous. And as you guys are grading FRQs for mock corrections, etc., you should be seeing that as well. On FRQs, they don't give you any points for doing the works of deriving or integrating. It's all meant to be done in the calculator. Problem equals decimal done. Whew. But Benny, go ahead and go first.
I got like the same answer, but I thought of it different.
Yeah, how'd you think of it?
I thought step 1 to step 2 should have been like an arc or something.
If there was a squared, let's see, hold on. What is that rule? Square root of u squared minus a squared, or a squared minus u squared. If it was a minus and the variable was squared, then I could have used arc sign. Or if there was something in front, like a y, and that had a squared with a minus, then that could have been an arcsecant. But it was missing a lot for an arcsecant. For an arc sine, it was just missing, it should have been 3 minus y squared. But yeah, remember, you have to have it fit for those guys. I mean, you were kind of lucky in the sense of this question, that's all you needed. So it was enough, right, to get the right answer. But the one you were thinking about is 1 over the square root of a squared minus u squared. That goes to arc sine. Or this one of 1 over, that's where the variable comes first, but careful, these are all still minuses. It's the tangent one. It's the tangent one that has a plus, but it also should have some sort of squares. Now this doesn't have to be obvious squared, but the variable does. But no square roots on this one, that's a plus.
So it's okay if it's like a 1 over u squared plus 9.
Yeah. Yeah, like x squared plus 9 or y squared plus 9 without the square root, that's totally arctangent. But yeah, your brain at least was recognizing it's not ln. So, almost on the right track on that. Yeah, please do. Unless you want to borrow, oh no, my batteries are dead. I think Emily's are on the back, is on the back desk if you want it. Andy, here we go. You guys don't have to do this whole one, it is in the video. We're just like taking a quick timeout, no timer, we're just talking about it because those of you that tried it, we're just seeing where the questions lie. So let's just see what the givens are. An apple pie cools in the kitchen counter, which means the temperature is going down, right? Pull it out of the oven, it's whatever that bubbling goodness temperature was. You'd probably be baking an apple pie at like 350, that's about right. So we'll assume that it got up to that temperature of 350 degrees Fahrenheit. Oh, it said when the pie was placed on the counter. Never mind. It started decreasing pretty fast. It was at 270 degrees Fahrenheit. That's a nice. That's a clue. That's an initial. That would be when time equals 0. The temperature is 270. And then it tells me this differential equation. Someone help me, please! And this is from our forevers and evers around the room. How do I know the slopes of tangent lines? Like this one's asking for when the slopes are horizontal. What tells me about slopes of tangents? Derivatives. So guess what? This guy tells me about slopes. So if it says, where are the horizontal slopes, what am I setting the derivative equal to?
0.
But what am I allowed to use? The equation that they gave me. Could you use your calculator? Sure. To be honest, it's probably easier in this one just to solve. Because can't I divide by this number and it goes poof away, and so I end up with y minus 70 equals 0, aka when y equals 70? Why did I put a degrees? Why didn't I say 70 minutes? Who is y? Because, do you see it?
You're crazy, bro.
Y equals f of t, and f is temperature, right? So y equals 70 degrees Fahrenheit. That's where I'm going to have, at that horizontal line, all my slopes be flat. Why do you think? Why do you think the temperature is going to level out at 70 degrees and have a horizontal asymptote at 7 degrees? Room temperature is 70 degrees, and so it's not going to get cooler than the room is. Unless you're putting it outside and it's kind of chilly, or it's like the middle of winter and you don't have your heater on. Anyway, but 70 degrees, that's fairly normal. I guess in my house it'd probably be like 68. But anyway, Andy.
Would you get marked off if you put, like, units, like you put degrees?
Degrees should be fine. I just threw in Fahrenheit just because.
So no, like, would you be marked off if you just wrote that, like, the number? Like,
It depends. You wouldn't, like, probably get a point taken away. It depends on how they're doing points. As you guys look at FRQs, some of them didn't give any points on units because there weren't really ones, or they just didn't care. But, I mean, it's possible, Andy, so always try if units are present. Always try. Find the particular solution to the differential equation, then use it to predict. Guys, there would be so many points here on an FRQ. And you would lose all the points if you don't start it right. But if you start it right, you'll start racking them in. And some of you know, like 4 points, 5 points could have made a world of difference on what your score is on the AP. Especially if we're kind of moving our way up. It could be the difference between a number grade or the next number grade, or vice versa. So check it, check it, check it. There's a forever card for this. Check it, check it, check it. There's a forever. That's going to spill and I'm going to be sad. What did I do with the slope fields? Solving by separation of variables. What's the very... Eyes. What's the very first step?
Separate.
How?
Times.
Multiply what? The dx. But what is it in this case? dt. So I'm going to multiply the dt. That's first things first. When I multiply the dt, usually you can start to get your bearings. Not like the physics way. I don't even know what that is. But the normal way. Because once that dt is up, who does not belong and needs to get divided to the other side?
y minus 7.
So I'm going to have y minus 70. You can think of it as 1 over, it makes it usually easier on most brains, or dy over y minus 70. I had to move the whole thing because it was multiplied. And all of a sudden, not only do I get the first point, but also the whole door is open. We want some open doors, right, some of us? The whole door is open to us just starting to rack in points. Rack in points how? Rack in points with things like, hey, they'll probably give me a point just for knowing this antiderivative. Woohoo! Plus C. They'll probably give me points for just knowing this antiderivative. Woohoo! And I just mimicked some of your really bad habits. Did you double check either in your brain or with math that there is no u prime that I have to account for? What's the derivative of y minus 70? Just 1. 1 like dy dx, so I'm okay. It's just 1. But I can go to there. Andy, I'm sorry, go ahead.
If it's like dy over a certain function, is it always going to be ln?
Well, it depends. You know how just a second ago we had that, square root of something? Wouldn't that be to the negative 1/2 power rule? Or didn't Benny bring up the whole idea of you could have something like this and then that's going to be an arctangent? Just keep your eyes open. But you can always try for ln first, and trying for ln is making the whole u the bottom. If you can make it 1 over u du, go to that ln. You got it. Okay. How do I finish solving this differential equation? Check it out on the video with Verge. ... She'll help you out. But I want you guys to use your calculators. Okay? I want you to use your calculators because they're gorgeous tools. And I know the questions on the calculator section doesn't always allow you to really get a 1-up. But these ones do. Can I please just give you a little something to think about, like maybe an FTC, but it's not that crazy long work that we did just a moment ago. It's like, no, we get to use our calculator to do most of this for us. We had to do this by hand, but if you have a calculator, you do it in the calculator. How? What function does a calculator have that is gorgeous? Alpha, window, integrate. Number 4. Or can you get there by going math? Sorry, math down. Function, integrate. You can also do math number 9, but you gross. That's kind of rough. I like alpha, window, 4. What else can the calculator do? Alpha, window, 3. You can take a derivative at a place. It needs to be able to be at a place. What else can you do? You can graph things and you can find things like maximums and minimums, which they're rarely asking of an actual graph. They're usually asking it with a derivative, so you probably want zeros or intersections. But use what you can to solve, and I'm going to put a timer up. Benny, what's up?
On like market groups, like videos.
Yeah.
They were able to derive.
Bless you.
They were able to derive like law on the graphing.
Yeah, you can do that. Usually I don't show you, well, I've shown you, probably not you, sorry, because you weren't here when we were doing it. You can on a graph like, I don't even know, let's do like 1/4 x squared.
Yeah.
Okay.
How's it going?
You can do just like we did right here, and I was showing the whole max min, like there is a dy dx and there is an integral. But you have to have like a window that includes, like if you're at something like 2, you'll be able to see, you can't see the tangent line unless you get a special program, but you can see what the derivative is, it's 1. The problem is, what if I want something like the derivative at, that's intersect, sorry, second trace 6, the derivative at something like 11.2, I need to actually make my window to where I can see the part that I want to take the derivative or the integral of. And sometimes the window is one of the hardest parts. Like, it'll just take time you know what I mean? You don't want to use. But yeah, you definitely can. Or similarly, you can also do an integral between like 0 to 2. So if you're looking at the picture anyway, then if you already have it typed in here, that's great. But I usually have you type it in and then just come to the home screen so you don't have to worry about the window. So you can do something like from 0 to 2, and then we can just do an alpha trace. We can just go steal the y1, like say you're looking at the graph. I like this better, but that's just me. Like, I don't like fooling with the window if I don't have to. Okay, 4 minutes. Use that calculator to its fullest potential. Go. These are gorgeous. Use that calculator. Josh, you don't have one? I think I have enough battery life for you to use mine. People on the video, go ahead and pause if you want that time. Okay, as I was reviewing some of the different things that you can do on your calculator, these ones are gorgeous. It's just, can you use the function? So on this guy, the one little bit of work that I would show as far as what I'm about to do in the calculator and hopefully check. Well, you guys tell me. You guys tell me. How can I get to 0 given h of 5? What could I have thought of? What could I have done? Basically what you can think of is h of 5 minus h of 0 is equal to, if you need to go back to the beginning, you totally can, but once you rearrange a few things, by adding h of 0, and then subtracting the whole integral, and that's all I would have to write like on an FRQ. And then I just go straight to my calculator and I do the whole shabam in there. So when you guys had that, Andy was showing me his and it was perfect. That 345.678. Yeah, it was. Although, here's something creative. Couldn't you maybe, instead of having to do two different things, couldn't you have done just one thing? And just typed 345.678 minus, and do it all at once? Anyway, up to you. There's the 0, there's the 5, here's my function, which was that 1/2 x cosine of 1.5, etc., etc., etc. Don't forget your dx, and what'd you guys get? You guys agree? C? Ha, C. Okay, so number 2. Mark. Oh, he got a question too. Can't have him feel left out. Mark drives his car along a straight highway. The velocity of his car at any time is given by, there it is. The velocity is in miles per hour. Okay, thank you. If he is at mile marker 12 when t equals 6, that sure sounds like the 0.612. Or you could think of it also as position of 6 is equal to 12. Determine the nearest mile marker at 6.5 hours. Don't they want x of 6.5? Cool kids, how different is this one than that one? Not much, right? Because can't I go ahead and just set up a cool little definite integral and say I'm going from 6 to 6.5. This one, though, I actually have my initial, not my final. This was an example of having the final. I'm going to use the subtraction. This one is an example of having the initial. So integration is net change. All I have to do is add this guy to the other side. So therefore, I'm going to have my final answer as he's 12 at 6, which means I would just have that 12 plus, and then I would do my definite integral from 6 to 6.5, right? Did anybody do that? Did they do 12 plus 6 to 6.5 and they threw in that nice little and hit enter? What'd you get? 46. But let me go ahead and show the math real fast. We would go ahead and add this guy to the other side, so the x of 6 plus, which would be the same thing as 12 plus. And then you're just plugging in that whole thing. Hitting, don't worry about the t's, right? Just make them x's. I don't care. That's fine. Just make them x's, and as long as you make that an x, it'll understand everything. And then you'll get that 46. We love our calculator.
Michelle,
Yep.
did you make your t equals 6 your initial condition? Is that why you
Yes.
went from 6 to 6.5?
Yes. So initial, like in physics, is usually like time equals 0, but it could also be something like 9 a.m. and we make it 9. You know what I mean? So in this one, they told me something, and whatever they told me, I made my initial. Whatever they told me, I made my initial. I'm like, start there, because I don't know anything else. Okay, so if you guys seem a little bit bored, so let me go ahead and show you where we are at. We technically have video 7 and video 8. Video 7 is another day of applications of integrals. There's going to be some with calculator and some without calculator. Oh, where'd the bats go? Was that over here and I just didn't get to it? No. Maybe they did the bats problem and I missed it. But anyway. I missed it somewhere. Oh, thank you. You're welcome. We have video 7 and 8, but with the amount of time that we have left, I did want to go ahead and peek at any mock corrections that you guys might have questions on. So we can keep going on 7 and 8 next week. And if you guys have questions like Andy did today on the apple pie one, please bring them to me. Because I'm going over questions you haven't seen before if you didn't do the whole handout. Oh, I did miss some. I don't know where it went. Oh, here they are. Yeah, there's the barn population. Okay, cool. So yeah, we have review 7 and we have review 8, and then we will be done with those videos. And once again, you do have a whole other set of videos you could be watching from 2022. But why don't you guys grab out your mock exams and let's see if there's anything that you have questions on. Josh sent something along in the chat. He was asking in Math Lab Zoom yesterday before the softball game a couple questions. And we were going to see how those FRQs went for him. So I'm pulling that up right now. And here we go. I have the mock AP number 1. I have a Jamboard for that where I'm just collecting some of the questions we're doing. Andy, what's up, bud?
I have a question on the mock.
Yeah, what do you got?
You gave us. No,
Oh, that I just gave you, yeah.
Oh, you didn't do that. Well, can you just like come and check mine?
Okay, I'll come and look. And meanwhile, the rest of you guys can get your mocks out and see if you have any specific questions. Let me get rid of that Jamboard. Let me open up this one. Josh wants me to go to... We didn't go over 86 yet, but we did go over 89. We did go over 90. Here we go. 1C, 3C, 4BC, 5B on FRQs. I'm just going to leave that up so I can get them. He's asking on FRQs, but I'll also try to get multiple choice if we still need them. Number 1 is totally a calculator problem too, although you didn't have to plug it into your calculator. We're going to the trapezoidal sum on 1C if you guys want to.
We're just like this on this.
There's no more work. Like, and then I think it's just, and then it'll
So you have to use 2
Oh.
Yeah. You tried to, like, I saw what you were doing, but you don't add them, make them separate.
What'd you put for
Oh, yeah.
16?
Anybody else have final note checks ready?
Oh yeah. I think sure.
I can do it next week, I'm just offering.
The math wasn't even ready.
Mark is done. You pause. The area of a trapezoid is what? Yeah, 1/2 B and then H1 plus H2. And so if I was thinking of these things in subintervals, I have to think of them as like going from one to the other, going from one to the other, going from one to the other. Like there are going to be 4 different subintervals because I'm going to be making 4 different, like there's a trapezoid, there's a trapezoid, there's a trapezoid. I need a base, and to have a base, I need to go a distance. Area is equal to 1/2 base, height 1 plus height 2, where my bases are my delta x's normally, but delta t's in this problem, and my heights are f of x's normally, but L of t's in this problem. So then I would have just, for the FRQ, said that the integral, well, the trapezoidal sum would be equal to, I would have been a little bit lazy and just written a big old fat 1/2 because every single trapezoid is going to have a 1/2. But then I would go ahead and figure out the base of the first one by saying what's in between, and that's 3, times height 1 plus height 2, what's on either side of that 3, a 15 and a 40. Sure, some of you can do that mental math, but I made enough, I had to take off enough points on the test that I asked you not to. As I make the next jump from 5 to 9, that's going to be a base of 4. And I look at what's on either side of those 2 numbers that made it, 40 and 24. Plus, I'm going to see what goes next. There's a base of 2 from 9 to 11 is 2. What's on either side is a 24 and a 68. And last but not least, from 11 to 12 is a 1. What's on either side is a 68 and an 18. If this was a left Riemann sum or a right Riemann sum, I wouldn't be using either side. I'd be using either the left height or the right height. And just doing base height and not the weird 1/2 average adding thing. But I would have put that, then I would have said something to the effect of which approximates the integral from 2 to 12 of L of t dt, which is, and what you guys sadly did, a lot of you, is you would state the integral and then you said approximate. The integral is not approximate, the integral is exact. The trapezoidal sum was the approximate. So this trapezoidal sum approximates the integral, which is the number of cars leaving, because I'm going from the rate of leaving back to the number of cars leaving, is the number of cars leaving from, and I think I remember from Lucas Fletcher working on this one, I think they're starting their initial at 5 a.m. So 2 hours after 5 a.m. would be 7 a.m. And then 12 hours after 5 a.m. is 5 p.m. Or you could have said something to the effect of from t equals 2 to 12 hours after 5 a.m. That could have also worked. But you couldn't say the integral approximates. The integral does not approximate. The trapezoidal sum approximates the integral, which is the number of cars leaving the lot. That was 1C. 3C is the next question that came in. Number 3 is a non-calculator question. But Benny, do you have a question on that one? Did I miss it? No. 3 gave us this nice little piecewise function, which I know a lot of you guys hated when you first saw it. It was a little too much maybe for that day for your brain to handle. But Andy was handling a piecewise in the back. They do tend to throw piecewises at you so that you remember or realize or are tested that you know this piece only works for this interval. That piece only works for that interval. If I go over both intervals, I have to look at both functions. We'll see how that is in just a second. But 3C, average value, has a forever card. Average value versus average rate. We talked about it yesterday. Nope, Wednesday. Sorry, whatevs. You know, that last time we were together. Average value has a forever card. And the forever card says 1 over b minus a, which is 4 minus negative 3, times the integral from, now normally I would just say negative 3 to 4. But as I just said, it behaves, the function behaves differently on 2 different integrals. So I'm going to go negative 3 to 0 of one of them, plus 0 to 4 of the other one. If I have 2 different pieces and I'm looking at x's in both of the regions, I have to split it up. And so when I split that up, like I've talked with a couple guys on this integral, or on this question, this first one is going to need to use geometry. And maybe we'll talk about that one a little bit longer another time, but geometry, because long story short, this guy ends up being a semicircle with a radius of 3. There is no mathematical way for you guys to integrate it. And if I'm going from negative 3 to 0, I'm going to be using the geometry formula of 1/4 pi r squared, where my r is the square root of this guy. This is a basic graph, r squared minus x squared, where r is my radius. So I'm going to throw in that 3. I have my little 1/7 chilling out here in front of the whole thing, and that's okay. I'm going to stick it to the man in a second anyway. But when I come to this part, I am going to have to anti-derive to have negative x squared over 2 plus, now I know this is going to be 6 over pi sine of pi x over 2, but I can do u substitution in my head. For most of you, that is an awful idea to do u substitution in your head. So therefore, I hope you would be coming off to the side and you would be thinking of these integrals as separate integrals. And you would be looking at this and saying u is equal to pi x over 2, which is the same thing as pi over 2x. Du is equal to pi over 2. My u prime needs to be accounted for, but to be accounted for, ever since the old power rule, we would move it to the other side. That reciprocal gets moved. So that's where that 2 over pi comes into my u substitution. 3 times 2 over pi, or 3 over 1 times 2 over pi is 6 over pi. So all I got to do to finish this problem is just plug in 1/7 times 1/4 pi times, sure you can make it a 9, I'm just being safer rather than sorry. Then I'm going to have to plug in the 4. I should not square the negative. The negative is totally separate. PEMDAS would say you square it and then you multiply by a negative. That negative is not grouped, so I'd leave that negative separate. Plus 6 over pi sine of 4 pi over 2. Sure, you could use your unit circle, but you have a numeric expression. You don't have to use your unit circle, which is gorgeous. Minus means I can leave it like this and stick it to the man. Negative 0 squared over 2. Yes, it's 0, but I'm being safe. Plus 6 over pi sine of 0 pi over 2. I put a big old bracket. You have to be very careful that that 1/7 is multiplied by everything. And then you have that entire average value done. Geometry was needed for the first half, or the first piece. Anti-differentiation was needed for the second piece. For number 4, oh bummer, I thought we got this one done. Number 4 is going to take a little bit more work. That might be one that we might look together with on Monday before I spot check the mock APs, because this is just a good function with an accumulator, and I know that some of you, like, this is hard. So I might just save that one unless someone wants to come to Math Lab or come into the Math Lab Zoom. But for number 5, this one is talking about Brandon and Chloe. And Brandon and Chloe had 2 different ways of being discussed or talked about. Brandon had a table, Chloe had a piecewise function, but both of them were giving me velocity. So when they ask in letter D, and this is where we're ending, when they ask in letter D, is there a time at which Brendan's velocity is equal to Chloe's velocity? Now, in context of the FRQ you've been building to this point, maybe some stuff from before applies. But I could look at a couple different things. For instance, I can think about how both Brendan and Chloe's velocities are continuous. Since they're continuous, I can say that IVT applies. So if I know what's going on at the beginning, 0, and at the end, 2. By IVT, I can say that all the in-between values happen. So if I were you, I would say, hey, what's Brendan's velocity at 2 minus Chloe's velocity at 2? See what that is. What's Brendan's velocity at 0 minus Chloe's velocity at 0? If I need to know that they're equal to each other at some point, what I need to know is that B of t minus C of t is equal to 0 somewhere. My brain is sending off all these like ding, 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 ding. I can have a guaranteed 0 if I have a sign change of the values. IVT, because this is continuous, because velocity in motion is continuous, IVT says if there's a sign change, there must be a 0. And a 0 of this subtraction would be them equaling each other. So all you gotta do is plug in 2, B of 2, which I already know because it's right up here, 1.5, taking from the table. B of 0 is 1. C of 2, I would plug and shove to what I have here, which is 2 e to the 4 minus 2 squared. You have to simplify that. Or 0, I'm plugging into the exact same thing, which would be 0 e to the 4 minus 0 squared. That guy's a 1. This guy is e to the 0 is 1 and 2. Is a negative 0.5. Bingo! Use IVT. There's a sign change, there's a 0 in between. Thank you guys for letting me help Josh out at the end of class. If you have things for me to spot check, I could do it today. Bring it by, drop it off on the desk. Emily and or I can spot check anything you have ready. Otherwise, I can do it on Monday as well.
Can you check some of my colleagues?
Yeah. Let me pause the recording so I can get loading for Jacqueline. Benny.